All right, welcome to lesson 3.14. Remember, we have a quiz tomorrow on writing and solving rational equations in context, so you'll want to do some review, go over some previous problems and real-world situations that we've done, and also take advantage of the problems here to get some extra practice. All right, so this is the first of three problems. You want to go ahead and copy each down. You should have this one already copied down. We'll take a look at it together and then move on to the next problem. All right, let's take a look here. First couple of steps should be pretty basic here. I'm trying to find the amount of acid that needs to be added. So that's X. And in this particular situation, I want to set my concentration equal to 0.705. So here's my equation that I'm going to use, and I'm going to set C equal to 0.705. You'll want to make sure you can solve this. You can always check it graphically to make sure. And you get that X is approximately 27.458, so you must add about 27.5 gallons of acid. Now, in part B, what you want to think about is instead of adding acid, I want to make the concentration lower. So I don't want to add any acid. Instead, I want to add water. And I want to add that to the total. So my new equation is going to be C of W, where W represents the water I'm adding. And that's going to be 6 over 20 plus W. So now I want my concentration to be below 5%. So this means my concentration must be less than 0.05. So here's my concentration. I want to set this to be less than 0.05. So I will have 6 over 20 plus W is less than 0.05. And then I can go ahead and solve here for W, and I will get that W must be greater than 100. Notice here that instead of an equal sign, I used this inequality here to dictate the inequality that I was told. If I kept the equal sign, okay, let's just imagine what that would have looked like. I would have gotten that W would have to be equal to 100. That would make the concentration equal to 0.05. But I don't want that. I want it to be below 5%. Well, that means that the amount of water I add has to be greater than 100, because when I increase the amount of water, that decreases the concentration, since I'd be increasing the total amount, or the denominator. So it can be really helpful to just put that inequality sign right at the beginning so that I don't have to make that adjustment to write my answer. Right? So my answer will be that I must add more than 100 gallons of water. The interesting thing to note here is that you can actually both increase and decrease the concentration of a solution, either by adding more of the pure substance or by adding more of a substance that is not the pure substance, like water. All right, so there's this problem and then one more problem. You're going to want to write both down, and I will go ahead and post these solutions in about 10 seconds and maybe give a thing or two on some tricky parts of each problem. But you should treat each one as if it is a test question and really focus on getting the correct answer written out on your own. Okay, so here, the key to this problem is recognizing that when they tell me that there are 500 liters of this solution and it's 10% peroxide, the concentration is 10%, meaning 10% of this is peroxide. And 10% of 500, I can multiply 500 by 0.1, and that'll give me 50 liters of pure peroxide. So my equation is going to be the concentration, which depends on the amount that I'm adding, X, will be 50 plus X over 500 plus X. Setting the concentration equal to 0.28 will give me a solution of 125, and therefore 125 gallons of peroxide must be added. There is no amount of pure peroxide that would create a 100% solution. We discussed this today in class. The reason is that there's always going to be this 450 liters that is not pure peroxide. So no matter how much I add, I'll get very close to 100 even if I add a very large amount, but I'll never quite be able to get there. All right, last problem here. Go ahead and give this one another try on your own. Focus on getting a solution that makes sense, and then go ahead and check your answers. All right, so again, Nothing too complicated here. We just have to be careful when they tell us the percentage of concentration at the beginning. So we're told that it's a 25% concentration of ethanol, and the total amount is 1 liter, 1 single liter. So when we multiply 1 by 0.25, we just get 0.25. So there is 0.25 liters of ethanol at the beginning. We're going to add X liters of ethanol in part A, and so my equation is going to be 0.25 plus X over 1 plus X. That's going to give me the concentration. So setting equal to 3 and solving, I get that I must add approximately 0.07 liters of ethanol. In part B here, I'm not going to be changing the pure concentration. I'm going to be adding only water to the total amount. And setting equal to 0.1 is going to give me that W should be 1.5, so I must add 1.5 liters of water. No, I can never reach a concentration of 0% because that would mean I would have no ethanol in there, and there's always going to be that 0.25 liters of ethanol. So since I'm assuming I probably can't extract it once it's been mixed in, I'm never going to end up with a 0% solution.